In this video, we will be taking a look at what are called ratios, rates, and unit rates. Let's start with what a ratio is. A ratio defined is the relation between the size, number, or amount of two different things. Best way to understand this is by looking at an example. So let's consider this example. We have a basket of fruit that contains 4 apples and 7 oranges. The question is, what are the different ways the relationship between apples and oranges can be expressed? We're going to take a look at 3 different ways that that relationship can be expressed. The first way it can be expressed is in what is called colon form. The colon refers to the colon symbol. And the 2 ways in colon form that we can write this relationship or this ratio is 4:7, or we could write it as 7:4, all depending on which fruit we are considering first, apples or oranges. This one right here communicates that there are 4 apples to every 7 oranges, or you could write it as there are 7 oranges to every 4 apples. So it shows the relative size of each compared next to each other. Now the second way that we can represent a ratio is through fractional form. Now fractional form, instead of comparing the size of each quantity to each other, it compares the size of one quantity to the total amount. If I have 4 apples and 7 oranges, that means I have 11 total pieces of fruit. So the 2 ways in fractional form that I can display this is 4 out of 11 or 7 out of 11. Each of these showing how much of each type of fruit there are out of the total. So 4 out of 11 is apples. There's 4 apples out of 11 pieces of fruit, or 7 oranges out of 11 pieces of fruit. The last way we can write a ratio is in percentage form. Percentage form does nothing but take the fractions and turns them into percentages. Now I'm going to round to the nearest hundredth. That's 2 decimal places. So I'm going to do 4 divided by 11, and that gives me a 0.36 rounded to 2 decimal places, which is actually a 36%. Okay. Now I'm going to do 7 divided by 11, and I end up with 0.64 rounded to 2 decimal places, which is 64%. So 36% of the fruit in the basket are apples, and 64% of the fruit in the basket are oranges. So these are the 3 different ways that you can represent a ratio, the comparison between 2 quantities. We now want to look at what's called a rate, which is a specific type of ratio. It is a measure, quantity, or frequency typically measured against another measure or quantity. To explain this, to give meaning to this definition, we're going to take a look at this example right here. A leaky faucet has leaked 17 gallons of water in the past 26 hours. The question is, what 2 ways could this ratio be written? Okay, so this rate here, what is a rate? It's a measure, quantity, or frequency typically measured against another measure or quantity. Rates are always written in fractional form. So there's 2 different fractions that we could write here to represent the rate. We could write 17 gallons per 26 hours. So notice that it compares a measurement or a quantity against another measurement or quantity. 17 gallons is measured against the 26 hours. in 17 gallons, or in 26 hours, 17 gallons has leaked. The other way we could write it is 26 hours per 17 gallons. Now, what is the difference between what these are communicating? This first one is communicating that 17 gallons has leaked in 26 hours. Here, the second one is communicating that 26 hours has passed by after 17 gallons has leaked from the faucet. The question is, what is the more natural rate to use? Now, the more natural rate to use is typically the unit that the second measure or quantity is measured in, and that is usually time. Okay, so the more natural one is when you have time on the bottom. So that would be 17 gallons per 26 hours. Think of it this way. A rate that most of you are used to is miles per hour. The time unit is on the bottom. How many miles have you traveled per hour? Or how many miles per hour are you currently traveling in your vehicle? So again, that is a rate. It's one unit or measure quantity or frequency measured against another. And the important thing to remember is the natural way to write a rate is having the time measurement on the bottom when time is involved. We now want to look at what is called a unit rate. In the previous slide, we constructed a rate of how many gallons of water leaked from a faucet in a specific amount of time. What we're going to do is we're going to look at another rate, but what we're going to be concerned with is simplifying it into what is called a unit rate. A unit rate is a rate simplified to have a denominator value of 1. A denominator value of 1. So let's see what this looks like. Here's an example. A school bus traveled 132 miles in 3 hours. First express this as a basic rate. So I've got my two quantities, 132 miles and 3 hours. Now we know that in a rate we typically want the denominator to be the time unit. So I'm going to write this as 132 miles per 3 hours. So we have our rate written here in basic form using the values that we were given in the information given in this problem statement. But it's a little bit awkward because I don't typically say, oh, the bus was traveling 132 miles per 3 hours. I simply say the bus was traveling X amount of miles per 1 hour. So that's what it means by we want to have it simplified, our rate simplified to have a denominator value of 1. To do that, to express it as a unit rate, what I want to do is I want to simply perform the division. So in my calculator, I'm going to do 132 divided by 3. And 132 divided by 3 is 44. So what I end up with is, as a unit rate, I end up with 44 miles per 1 hour. Now you could just simply write it as 44 miles per hour since the denominator is just a 1. Just put the units in fractional form since the denominator is just a 1. So I've traveled 44 miles in 1 hour. That's the rate, the unit rate at which this bus is traveling, 44 miles per hour. Now, one of the reasons this is useful is it allows us to answer other questions. So take a look at this last question here. How many miles will the bus have traveled if it travels for 7 hours? Assuming that it's staying at this unit rate of 44 miles per hour, how far will we have traveled in 7 hours? Well, to do that, what I'm going to do is I'm going to write it as 44 miles over 1 hour. And then what I'm going to simply do is I know that I need to find how many miles. And I know that I've traveled 7 hours. So to cancel out hours and be left with nothing but miles, what I'm going to do is I'm going to multiply 44 miles per hour by 7 hours. What you'll notice is that since I have hours top and bottom, hours cancel out the unit and I'm simply left with miles. Now I just need to do the 44 miles times the 7 hours. And when I do that, I get 308, and the only unit left is miles. So in that time period of 7 hours, if the bus stayed at the same unit rate of 44 miles per hour, I will have traveled 308 miles.